Ladies and gentlemen, welcome back to Hanson Math video tutorials. Today we're working on synthetic division. I have 4 examples that you might find helpful. And off we go. Okay, first of all, you need to know a little bit of background information on synthetic division. Synthetic division is really useful when you're trying to find roots of polynomials. And it works where you take a polynomial, such as this one here, and you divide by a binomial. Synthetic division works for binomials, which is this guy here. And not only does synthetic division work for binomials, the coefficient on the variable, it needs to be 1. If it's not 1, you can still do synthetic division, you just have to do more work, which I'll show in a subsequent example. Okay? So again, synthetic division works when you have a binomial, when you have the 2 terms here, and it works when the coefficient on the variable is 1. So, if you have that, what you do is the following. You take your binomial divisor and you take the opposite of what's after the variable. Here's our variable x, after it is -3. The opposite of -3 is 3. That goes here. That is your divisor. Now the dividend, this big polynomial here, synthetic division is a shortcut. You need only write down the coefficients in order from highest power descending to lowest power. So we have a 6, boom, -19, boom. This x here has a coefficient of 1 right here, and the constant is 6. Now, once you have that, what I do is I draw what I call my answer line, which is this one. My answer goes underneath that, and I draw this, which is called the remainder line. That goes in front of the constant here, and then the remainder goes in this area right here. It's kind of boxed off. Okay, that's the setup for synthetic division. Now, steps. How do you compute it? Well, you take your first coefficient and you bring it down. You always drop it down. So 6 drops down, and then you multiply back. 6 times 3 is 18. That goes right here. Now, synthetic division, unlike long division, you add when you go down the column. So -19 plus 18 is -1. Anytime you're underneath the answer line, you multiply back. And that answer goes under the next term. -1 times 3 is -3. That goes right here. You add 1 plus -3 is -2. You're under the answer line, multiply back. -2 times 3 is -6, and lo and behold, 6 plus -6 is a remainder of 0. There is no remainder in this problem. Okay, so how do you take these coefficients here and put them back into a polynomial form? Well, when you synthetic divide, you always lose a power. So what I mean by that is the following. Our original dividend, the highest power was 3. So now the answer goes down to the second power. So this becomes 6x to the second, or squared, minus just the 1x minus 2. Another way you can explain it is the constant always goes right before the remainder. So it goes constant, first power, second power. So that's it. 6x squared minus x minus 2 is done. No remainder. Okay? Feel free to review this if you need to. If not, we will go on to the next. In example 2, this problem has specifically been chosen because it illustrates how you handle the descending power of the exponents, and it's very important that you account for all powers, as I'm about to explain. Here we have 6w to the 5th plus 18w squared plus 150 divided by the binomial w plus 2. Now note, the coefficient on w is 1, so that's good, and after that is a plus 2. The opposite of that is minus 2. That's why minus 2 goes in the box like so. That's perfect here. Now, as far as our coefficients on the dividend, you start with the highest power, which is in fact w to the 5th. The coefficient there is 6. Boom, here it goes. Now, the next lowest power after w to the 5th would be w to the 4th. But notice there is no w to the 4th here. So that's why you have to leave a placeholder 0. This means that there's 0 w to the 4th. There is also no w to the 3rd, hence another 0. In the w squared column, we do have 18 of w squared. Boom, there it goes. And there is no w to the first power. Therefore, another 0 placeholder, and we do have a constant of 150. Remainder line, answer line, remainder line, like we did in the previous example, and we're set to go. But it's very important to put in those placeholder zeros for the missing powers in descending order. All right, take your first coefficient, drag it down. 6, multiply back. 6 times -2, -12. Add straight down, 0 plus -12, -12. Multiply that back. -12 times -2 is positive 24. Add straight down, 0 plus 24, 24. Multiply that back. 24 times -2, -48. Add that column down. Positive 18 minus 48, you're in the hole, minus 30. Multiply that back. -30 times -2 is positive 60. Add that column straight down. 0 plus 60 is still 60. Multiply that. 60 times -2 is -120. And you have a remainder of, let's see, 150 minus 120 is a remainder of 30. Okay, we do have a remainder here, so let's see how we write that up. The highest power in the original problem was to the 5th power, so that means our answer starts to the 4th, because you always lose a power in the answer. So we have 6w to the 4th minus 12w to the 3rd plus 24w squared minus 30w plus 60 plus, I ran out of room here for the remainder. Our remainder is 30. You express the remainder as a fraction of the original divisor. Now the original divisor was w plus 2, so that 30 remainder is expressed as a fraction, 30 over w plus 2. Again, normally you'd write it all in one line, but I ran out of room, so there's your answer. Okay, that's how you deal with the remainder. The remainder is written as a fraction over the original divisor. And you'll see that again in another example. 2 down, 2 to go. Next. The next example was chosen because sometimes you're given a problem which is out of order, such as this guy. The highest power here is to the 3rd. It's not the first term. This is all messed up. So what I'd like to do is rewrite it. So you start with the highest power. So that's 3a to the 3rd. Next we have a positive 6a squared. Okay, after that we have a negative 18a. And then our constant is positive 9. This is all being divided by negative 3 plus 3a. Well, if you again put that in order so that the variable comes first, that would be 3a, and then a negative 3 is the same as minus 3. Okay? I hope that makes sense. I'm just rewriting it in terms of descending powers. Now, a big change in this one is our coefficient on the variable a in this binomial divisor here, it's not 1. It needs to be 1. So to get this 3 to become 1, you can't do any magic. The only thing you can do is divide. To get 1, you divide something by itself. So since this coefficient is 3, you divide it by itself, which is 3. But the thing is, in algebra, what you do to one side, you have to do to the other to keep it balanced. So if I divide this term by 3, everything, literally every term in the whole problem has to be divided by 3. Everything. So each term everywhere divided by 3. Very important. Now, essentially what we're going to do is we're going to simplify this and then kind of start from scratch. So if you simplify this, 3 over 3, that cancels, so you have a to the 3rd. Over here you have 6 divided by 3, that's 2a squared, minus 18 over 3 is 6a, plus 9 over 3 is 3, and we're dividing by 3 over 3, that's 1a, minus 3 over 3 is 1. Okay, now we're in good shape here. We have our polynomial division such that the coefficient on our variable in the divisor is 1. So again, we take the opposite of what's after that. The opposite of -1 is a positive 1. That goes in a little box. And now our coefficients. From the highest power, the coefficient on a cubed is just 1. Next, the coefficient here is 2. The coefficient here is -6. And our constant is 3. Answer line, remainder line. Drop down the first coefficient and multiply back. 1 times 1, 1. Add columns. 2 plus 1, 3. Multiply back. 3 times 1, 3. Add the column. -6 plus 3, -3. Multiply back. -3 times 1, -3. 3 plus -3, remainder of 0. I like that. The original problem had a highest power of 3, so our answer goes down to 2. So we have 1a to the second plus 3a minus a constant 3, and there is no remainder, so that is a wrap. Okay, that one illustrates how to deal with a situation where the variable in the divisor does not have a coefficient of 1. We'll see one more challenging example of that next, and then this video will have come to fruition. Okay, finally, example 4. Notice that in our dividend, we do have descending powers, k to the third, second, first, and constant, and we're dividing by 9k plus 7. This is a binomial, which is good, but the coefficient in front of the k is not 1. So to undo the 9, you have to divide by 9, but like we did in the previous example, you have to divide by 9 everywhere, and if you're pretty math savvy, you're going to notice that most of these coefficients are not divisible by 9. That's okay, we just have to deal with the fractions. We'll do what we can here. 9 over 9 here, that does simplify to 1 whole, so we have 1 whole k to the third minus 83 over 9 is not going to simplify nicely, so we leave that as 83 over 9 k squared minus, again, 43 over 9, not going to simplify, so we leave that as 43 over 9, and 26 over 9, same story, not going to simplify nicely at all. Alright, so there is our dividend. Now, dividing by the divisor, we simplify that here. 9 over 9 is just 1 k plus 7 over 9. That's going to remain 7 over 9. That does not simplify well. But we're in familiar territory now. We're ready to go. Here's our variable k. You take the opposite of what comes after it. The opposite of positive 7/9 is minus or negative 7/9. That goes in the little divisor box. And now we write down our coefficients, starting with the highest power. Coefficient here on k cubed is just 1. Next we have a negative 83 over 9, followed by a negative 43 over 9. Finally, our constant is 26 over 9. Answer line, remainder line. All right. Drop down the first coefficient, multiply back. 1 times -7/9 is -7/9. Now, adding the column here, -83 plus -7 is -90/9. Okay, I'm going to write that out. We'll simplify it later. -90/9 is the same as -10, right? Because -90 divided by 9 is -10. So I'll kind of cross that off, and underneath here I'll put -10. Now we'll multiply that back. -10 times -7/9 is positive 70/9. When you add that, -43 takes away from positive 70. It leaves us with, what would that be, 27/9. So we've got 27/9. Now that one comes out to a whole number because 27 divided by 9 is 3. So now we have 3. Multiply that back. 3 times -7/9 is -21/9. Adding this column, 26 minus 21, since we're counting by ninths, 26 minus 21 is 5 ninths. So there is our remainder. Okay? So the original highest power was the third. That means our answer starts to the second. So we have 1k squared minus 10k plus 3 plus our remainder was 5 ninths. But what you have to do is you have to express the remainder as a fraction of the original divisor. The original divisor was this one, 9k plus 7, so we have to keep that as the denominator of a remainder here, 9k, if I said minus I apologize, 9k plus 7. Again, where am I getting this from? It was the original before we started the problem. It was the original divisor, 9k plus 7. That has to go as the bottom of your fraction for the remainder. Now, this 5 ninths on top, that was a remainder after we divided everything by 9 so that we could do the division. So basically what you have to do is you have to undo the divide by 9. So if you undo dividing by 9, that's multiplying by 9. So 5 ninths times 9, the 9s would cancel, so you'd be left with 5. Okay, so this is the proper way to do the remainder here. It's 5 over the original divisor of 9k plus 7. So you don't want to do 5 ninths over the denominator here. Okay, you want to undo whatever you divided by all the way. We divided everything here by 9, so you want to undo that. The opposite of dividing by 9 is times 9. Those would cancel, so you're left with 5, which goes right here. And this is your final answer. K squared minus 10k plus 3 plus 5 over 9k plus 7. I hope you find these answers helpful. And once again, I want to thank you for supporting HansonMath.com tutorial videos. Have a great day.